हेलो स्टूडेंट्स, मैं बीएल शर्मा, मैथ्स। विल डिस्कस चैप्टर 9 of class 10th mathematics, that is some applications of trigonometry. Here I will be discussing three examples. Example number 1, 2 and 3 of chapter 9. But before that, we should know about angle of elevation, angle of depression and line of sight. Let BC is a building or a tower, and we are standing here. We observe point C from point A. ये एक बिल्डिंग है, यहाँ पे एक पॉइंट O A है जहां से हम C पॉइंट को ऑब्जर्व कर रहे हैं। मींस जिस पॉइंट को हम ऑब्जर्व कर रहे हैं वो ये जो हॉरिजॉन्टल लाइन है उसके ऊपर की तरफ है, दैट इज अबाउ द हॉरिजॉन्टल लाइन. So this angle is said to be, this is horizontal line and this is line of sight. This angle is said to be, this angle is angle of elevation. And later we are here and we observe a point which is on the ground at point A. Then this angle is said to be or known as angle of depression. एंगल ऑफ एलिवेशन और एंगल ऑफ डिप्रेशन दोनों ही एंगल्स इक्वल होते हैं. वी सी दिस एंगल is equal to this angle. Angle of elevation is equal to angle of depression. But when we say angle of elevation, इसका मतलब है कि हमें सर को हेड को ऊपर की तरफ करके देखना पड़ेगा. The point which we are observing, that is above our head. नीचे से ऊपर की तरफ. Angle of depression ऊपर से नीचे की तरफ. See here, that is angle of depression. This is angle of depression. This angle, ये नहीं angle of depression. This is not angle of depression, right? So, and this line is said to be, जिसके along हम देख रहे हैं, this line is said to be line of sight. The basic concept of this chapter, that is, we have to determine the height, distance, and height, in which in a right angle triangle, if one acute angle and one side is given to us, then we can calculate remaining two sides by the help of T ratios. And these are T ratios: sine theta, cos theta, tan theta, means perpendicular upon hypotenuse, base upon hypotenuse, that is cos theta, perpendicular upon base, that is tan theta, hypotenuse upon perpendicular, that is cosec theta, hypotenuse upon base, that is sec theta, and base upon perpendicular, that is cos theta. At the same time, हम ये जो वैल्यूज है 30 डिग्री, 45 डिग्री और 60 डिग्री के लिए सारे एंगल्स का हमें इनकी वैल्यू पता होना चाहिए. So let us start example number 1. We read the question carefully. A tower stands vertically on the ground. From a point on the ground which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degree. Find the height of the tower. Here, let AB is the tower. Here, tower is in this figure. Tower, that is AB. And the angle of elevation means angle BCA, that is 60 degree. And the distance of point B to C, that is 15 meters. Now, in this right angle triangle, since this angle is 90 degree, and this is right angle triangle, ABCA, BC is a right angle triangle. इसमें एक acute angle given है 60 degree और one side is given 15 meter. Using trigonometric ratios, we can calculate, we can find out the remaining two sides. So now, in the right triangle ABC, AB upon BC, see here, for this acute angle 60 degree, AB is perpendicular, BC is base. Perpendicular upon base is equal to tan theta. Here theta is 60 degree. So AB is equal to BC into tan 60 degree. BC is given 15 meter and the value of tan 60 degree is root 3. So we can write here root 3. Therefore, we can write that the height of the tower is 15 root 3 meter. Answer. So this is the answer of this question. Second example, an electrician has to see here. Read the question carefully. An electrician has to repair electric fault on a pole of height 5 meter. This is a pole, AD is a pole, so we can write here the pole that is AD, that is 5 meter. She needs to reach a point 1.3 meter below the top of the pole. A is top of the pole and D is bottom or foot of the pole. यहाँ से इलेक्ट्रिक फॉल्ट को ठीक करने के लिए यहाँ आना पड़ेगा and that is given 1.3 meter. So AB that is 1.3 meter. Therefore, BD will be 5 minus 1.3 meter, that is 3.7 meter. So BD is 3 point, that is B to D. Now in right angle triangle BDC, we have one acute angle 60 degree and one side 3.7 meter. So using trigonometric ratios, we can calculate the remaining two sides, mean BC and DC. BC is length of ladder here. What should be the length of the ladder that she should use which when inclined at an angle of 60 degree to the horizontal would enable her to reach the required position. Also, how far from the foot of the pole should she place the foot of the ladder? दूसरा क्वेश्चन ये है कि फुट ऑफ द पोल है उसको कितनी दूरी पे लेडर को रखना चाहिए. So first of all we have to calculate BC. So now in right triangle BDC, AC upon BD, देखिए सॉरी BC upon BD, this is BC. BC is a hypotenuse because it is opposite to the right angle. This angle is 90 degree. So that is hypotenuse. And BD is perpendicular. For this acute angle 60 degree, BD is perpendicular and BC is hypotenuse. Hypotenuse upon perpendicular is sec theta here. So BC we have to calculate. BD is 3.7 meter and that is cosec 60 degree. So BC that is 3.7 and cosec 60, the value of cosec 60 that is 2 upon root 3. You rationalize the denominator by multiplying numerator and denominator by root 3. So we can write 7.4 into 1.73 upon 3. And that will be approximately on calculating 4.2 meter approximately. So we can write here that length of ladder that is 4.2 meter approx answer. Means this length of ladder here to here is around 4.28 meter. Now here are two questions. Second question is how far from the foot of the pole should she place the foot of the ladder? यहाँ ये फुट ऑफ पोल है और ये आपका लेडर का फुट है, ये डिस्टेंस कितना होना चाहिए? सो for the next part, see here. Again in right triangle BDC, we have to calculate DC. We have been given BD. See, for the 60 degree, DC is base and BD is perpendicular. Base upon perpendicular is chord, and here acute angle is 60 degree. So DC BD is 3.7 into chord 60 is 1 upon root 3. We can write 7.3. Rationalize the denominator. And 3.7, 1.73 upon 3. On calculating, that is, on calculating, it will come around 2.14 meter. Therefore, we can write the answer here. The distance therefore, distance from foot of ladder to foot of pole should be 2.14 meter approximately. Answer. You also have to write approximately here. यहां से जो डिस्टेंस सी से डी का डिस्टेंस है वो होना चाहिए कितना? अप्रोक्सीमेटली 2.14 meter, and this is the answer of the second part of this question. Example number 3. An observer 1.5 meter tall is 28.5 meter away from a chimney. This is our chimney. और जो इसका डिस्टेंस है देखिए, ये एक मैन है CD. The observer height of observer, that is CD, and that is 1.5 meter in the question. And the distance BE, it is given 28.5 meter. ये जो डिस्टेंस यहाँ से यहाँ का डिस्टेंस है वो है 28.5 meter. And the angle is given, so therefore, and so now in and this AB is the chimney. The chimney you can write here. But first of all, in right triangle AED, we calculate AE upon DE. For this angle of 45 degree, that is AE perpendicular, DE is base, perpendicular upon base, that is tan theta, and here theta is 45 degree. So we can write AA is equal to BE into 10 45 degree. So DE is 28.5 and 10 45 is 1, that is 28.5 meter. But the height of the chimney, that is AE plus PE. AE is 28.5 because this is 28.5. BE, it is already given, that is 1.5 meter. So that is 30 meter. So height of the chimney is 30 meter, and this is the answer of the question. You will see here to here, ये हमारा है 28.5 and here to here that is 1.5. दोनों को जब ऐड करेंगे that will be 30 meter. So height of the chimney, that is 30 meter. So thank you.